Hey there, welcome back to the Wi-Fi Wheeler. In this video, I want to talk more about DC motors, but then specifically talk about how the DC motors work on our Wi-Fi Wheeler. So in the previous video, we went into just how do you turn on a DC motor, how do you change the speed, how do you change the direction, and we demonstrated it using these motors right here. Okay, so I'm going to move these now. If you want to see that, that is in the previous video. And just a short recap, what did we learn? Okay, so in order to turn on the motor, all you gotta do is give it a battery, give it a voltage. Okay, and once you do that, you're gonna get the motor to spin. Now, to get to spin the other way, what you gotta do is just flip the battery connections, and the motor will go spin in the other direction. And then we also tried out, in order to increase the speed, you just add more voltage. So we tried it with 2 batteries, we turned it on, and we saw that the motor moved faster. Again, you can see that in the previous video if you want. So now we know how to increase the speed and also decrease the speed. If we wanted to go with a lower speed, you just make the voltage even lower. So knowing that, let's take a look at our Wi-Fi Wheeler here. All right, so this is our Wi-Fi Wheeler. And I want to bring your attention to this, the DC driver. Now, we connected this to our computer WeMOS board here. So this is the main brain, okay, that's going to be controlling everything. And this is kind of like, I call it like the muscle. It's kind of like a mini brain too, or a muscle. The reason I call it the muscle is because ultimately the brain, it needs to move these motors here, okay? But the brain can't just directly connect to these motors because it needs more power. It needs to send power out to move these wheels, right? So then it needs, I'm going to call it the muscle. Let's call it the muscle. The muscle here, so that the brain will tell the muscle to move, and the muscle will then do the heavy lifting to move these motors, okay? So we're going to call, this is the muscle, and the technical term is DC driver. Now we have some connections here that we already did, but now let's move it over. Look at the, let's move my screen over, and here are the connections that we already made. All right. Okay, I won't go deep into it because we already made the connections, but I do want to explain a little bit more about what's going on here. All right, so we got two wheels, okay, with 2 motors, a left wheel motor and a right wheel motor. So I have them up here. Now the left wheel is connected to motor B connection, these green terminals here. The right wheel is connected to the motor A connection up here, okay, and those can be seen with my finger, where my finger's pointing right here. Okay, so we did those already. And then now if we look closer, we're gonna see these 6 other pins, which we've already connected. If you look at these pins right here where my finger's tapping, okay. We have B1A, B2A. So these 2 pins control motor B. And then we have A1A and A1B on this side. These 2 control motor A. The way you know is the first letter, okay? If the first letter starts with A, then it controls motor A. If the first letter starts with B, it controls motor B. All right, so now we know that these pins, now we know which pins control which motors, and it's a set of 2. Now, why is it a set of 2? Does it kind of make sense? So 2 pins to control 1 motor. Let's look back at our previous learnings over here. Look, remember the 1 motor right here? 2 pins, right? We had a red wire and a black wire. So if we have 2 motors, like in this case we have 2 motors, right? 1 motor here, 1 motor here. You need 2 pins for each motor, which is a total of 4 pins. So going back here, look, 1, 2, 3, 4. Okay, I wanted to make that connection, right? So we did it just with our hands, but now that the DC driver and the brain is going to help us do all that, we need to see there's still a connection. It still has to make sense. So yeah, so we got 2 pins for each motor, total of 4. Now what are the 2 in between? There's a GND here and a VCC. So that's to power the driver board. Okay, so GND is like the minus of the main power. That just connects to GND here. And then VCC, we connected it to, which is going to be the main power, the maximum voltage or the maximum power for the motors. That's going to go to 5V. So what does that tell us? That tells us that the maximum voltage for the motors is going to be 5 volts. Okay. So can you do 10 volts? No, you can't. But what you will be able to do is set the voltage on the motor anywhere between 0 and 5 volts. If that makes sense. And if you remember what we learned, if you set the voltage to if you adjust the voltage, you can then adjust the speed. All right. Again, maximum 5 volts because we have a 5V here. If this said 10V, 10 volts, then yeah, you could go even higher speed, but that's not what we got. We got 5 volts here. Now let's move over to this table here that I kind of set up for you so that we could talk more. Okay. Oh, and also just real quick, right? So these connectors are these pins. I drew the lines in. These will show you that we use D0, D1, D2, and D3 to control the voltages on the motor. Okay. And let's just go over here to the code. Now you see here D0, D1, D2, and D3. All right, those are the 4 pins that control the 2 motors. So basically what we're going to do through the code is control those 2 pins or those 4 pins, and those will then adjust the voltages on the motors, and we'll be able to control the speed and also the direction. Okay, just hoping that this all kind of is connecting for you. Whenever I do these videos, I just want to make sure, I want to give you the opportunity to not just make the robot move, but understand why it's moving, all the way down to the electronic part of it. Okay, so let's look at this table here. So we've established that, oh, I made a mistake here. This is not right. B1A and B2A controls the left, and then A1A, and then this should be, let's see if I can get this fixed here. Apologies. Here, this should be A1 and A2A. Those typo, here we go, A1B. Okay, A1A and A1B, those control the right wheel. Okay, so let's do this. Over here on these 2 columns here, we're going to write the voltage. All right, so we have, let's say if A1A is at 5 volts and B2A, again, these are the 2 wires that control the left wheel, is at 0 volts, what's going to happen? Well, that means you have 5 volts. It's the same thing as having like a 5-volt battery across those 2 wires on the motor. Then it's going to spin. So I'm just going to say this symbol for it's going to be spinning. Okay. Now, which way is it, counterclockwise, clockwise? I'm not sure. But for now, it's just the important thing is it spins. Now, what if you want to flip it? What if you want to have it spin the other way? So I'm going to draw some. What if you want to have it spin the other way? Well, then you just flip the voltage, right? So you would say 0 volts on this one and 5 volts on that one. Just like when we flip the battery in the previous video, it would just spin the other way. All right? Is this making sense here? Okay. So the first one here, we max speed one way, and then the second option here is the max speed the other way. Now, what if you did 0 volts and 0 volts on both? It's basically no power. What's going to happen? Nothing. It's going to stop. So that's how you stop it. Okay. Now, this is kind of a trick question. What if you put 5 volts and 5 volts on it? So both are connected to 5 volts. Does that mean 5 plus 5 is 10? We get 10 volts? No. So the way that voltage works is another way of when I was learning about electronics, how to describe voltage is potential. So potential is the difference between two levels. All right. So if you have, let's look at the first example. If you have 5 volts up on one side and 0 volts there, look, you have a 5 minus 0 is 5. 5 minus 0 is 5. So you have a 5 volt difference. If you look at my camera here on the top right. Now if I flip it, I have 0 volts here and then 5 volts here. What do you have now? If you do the math the same way, it's going to be negative 5. You have negative 5. So you do have a difference. It's just negative the other way. And that's why it spins the other way. But what if you have 0 and 0? Is there a potential difference? Is there a difference between? No. That means no potential, no voltage, nothing happens. Now, if they're both at 5, you have one that goes up and the other one goes up too. Is there a difference between them? Is there a voltage potential? Meaning, is there a difference between the two levels? No. So it's actually 5 minus 5 is 0. It's still 0 volts. Okay, so it might be kind of confusing, but if you think of that voltage is actually the difference between the two wires, then it makes sense. Right? You have to subtract them out. So 5 minus 5, even though one's at 5, the other one's at 5, it doesn't become 10. It subtracts from each other, so it becomes 0 again, and also stops. Okay? Cool. Now the same thing, so that describes the left wheel, LW, and then the right wheel, same exact thing. Okay? You flip it. Goes the other way. If they're both at 0, nothing. If they're both at 5, nothing. Okay? So, cool. So we're good there, but what about the speed changing thing, right? So what we do is, I'm going to actually erase what I just did on the other one. And let's talk about, okay, I'm going to leave this side here, the left wheel. Let's talk about the right wheel. Let's say if we want the right wheel to not be max speed, okay? So if we look at this one right here, right? This has 5 volts and 0 volts. That means it's going max speed one direction. What if I want it to go half speed? Well, then you would say 2.5 volts on one and 0 volts on one. Then you have, I don't know, I'll just do like a dotted. Then it's half speed. What if I want it even slower? Well, could I do 1 volt and 0 volts on this one? Yeah. I don't know how to do, I didn't plan this out. Okay, I'll do a small dotted circle, means it's slower. Okay, and then now if I go, what if I do 0.5 volts? Then it's going to be even slower. A little tiny. That's supposed to be a little tiny dotted circle with the arrow. Okay, so you get the point now, right? You can change the speed by changing the voltage on these pins, and then you can also do the same the other way, right? So half speed, let's do right wheel, half speed, but going the other direction. What would you do? You would do 0 here and 2.5. And then it would be going half speed the other way. Okay, give me a second to let this sink in. So we've established, just to recap what we've established, we know that each wheel has 2 pins that, 2 signals that control it. Left wheel is B1A and B2A. Right wheel is A1A and A1B. Now those two pins on each wheel, they act like a battery. Now you can change the voltage of that battery for each wheel, and that will control the speed, as we talked about here, and also the direction, which we've shown. If you flip the voltage, it changes direction. So we know that we can change speed and direction for both wheels individually. Cool. The last thing I'm going to leave here, excuse me, is this idea of digital and analog. All right. Very important. Once we get this, then we can jump into the code. Okay, digital, if you look on the left side here, digital means that it's either high or low. So there's only two values for the pins. So if you look on this area, the B1A and B2A, the pin is either 5 or 0. Okay, so what that means is you can either go max speed or no speed, right? So what else is another word for digital is like binary. It's either on or off. It's like asking, did you have a good day? Yes or no. Okay, yes or no. But usually it's like in between, right? So it's sometimes digital is just, again, it's like binary, yes or no. It doesn't really describe everything that I want to do. So just like the wheels, I don't want to just go full speed or off. I want to be able to control the speed. So then you need analog. So on this side, let me move this side. If you want to control, if you want to go 2.5, you want to go 1, you're going to want 2.6, 2.8, then you want to go analog. So the way the code is set up in our Wi-Fi wheeler is we use analog so that we're able to go into all the in-between speeds. Oop. Yeah, I'm just trying to underline. So we can do all the in-between speeds. All right, now let me say one more thing so that when we look at the code, it doesn't just look crazy. When we look at analog in computer code, this is what's going to happen. Okay, I'm going to try my best here. This is going to represent our 0 volts to 5 volts. Okay? So the digital is just, you're either right here at 0 or you're right here. Okay? Now with analog, it means you can be within any part of this this spectrum, right? Okay? So what the computer has to do though is, in a sense, because computers, they speak in, you might have heard this before, they speak in zeros and ones. Computers are binary, all right? But how do you go from a binary thing to analog, where you can do any number? For our conversation, the way you do that is you're going to take the 0 and 5 and you're going to split it up into different segments. So the way our the WeMOS board that works is it takes the 0 to 5 volts and it splits it up into a bunch of segments, and specifically 256 segments. Okay? So it takes a 0 to 5 volts and splits it up into 256 in the computer code. When you want to say define how many volts, then you have to tell it how many segments, and it's going to be 0, or which segment. It's going to be 0 to 255. Okay? Because if you start from 0, count starting from 0 to 255, it comes out to 256 different segments. Kind of confusing, maybe, but let me say it again. 256 segments for the 5 volts. It's cut up into 256, and to access all the different segments, you code it at a number, any number between 0 and 255. If it started at 1, it would go 1 to 256. But because it starts at 0, it's 0 to 255. So example, let's say if I want let's say if I want 5 volts in my code, I would say if I want 5 volts in my code, I would say 255 because that's the maximum. So I'm going to tell the analog value of 255. It means I want the last segment there. If I wanted a 0, I would just set analog 0. Now, if I wanted somewhere like 2.5 volts, what would I do? I would put it in between there. I would say 128. So 128 is actually 2.5 volts. Okay? I want to throw that out there because now when we look at the code, it's not going to look like some crazy language. So it's going to make some sense. All right, so now let's look into the code a little bit. We're not going to actually code. I just want to show you the code real quick, and then in the next video, we'll do some more active coding with everything we've learned. All right, so if we go here, okay, check it out. Okay, I'm kind of move my logo here so that we can actually code. All right, so where's my driver? Ooh, look. Okay. Stop all motors. This is a function that stops all the motors. Look, I am using analog because remember I said I want to be able to control all the different speeds, so I'm using analog write. There's also a digital write command, but now you could probably guess what does digital write do. It can only go max speed or stop. I want to do in the middle, so I want to use the analog write command, and it's controlling these first two commands control the motor A, and it sets it both to 0 volts. Okay. And then the second two controls motor B, sets it them both to 0 volts. What's going to happen? No motion, no voltage, stops. Now move forward. What's going on here? Okay. It's saying motor A, one of the pins go to 0, and then motor B, one of the pins go max speed times 0.5. What's max speed? Let's go up. Oh, max speed is 255. Didn't we talk about 255? Look, at 255 is max speed. Okay, it's making sense now, right? So I have a macro here. Max speed is 255, and I said I've just put a little comment here. It can be the speed of the car can be set between any value between 0 and 255. But now you know where that comes from. And then I say times 0.5 because I want it. I say I have a comment here. I want it to move at half speed when I go move forward. So what's 255 times 0.5? 128 around there. Okay. So now I'm setting it to this. When you do this math, it's going to set to 128. Okay. You say 127.5, but it was just going to round it to 128, which is fine. You know, we don't need it to be exact. If you look at the speed, 127 versus 128, you're not going to be able to tell the difference. All right, so now we know how this is working. So this is, after we do the math, it's going to say 128 here. It's going to move one motor one direction, and then the other motor, it's also setting you want to set at the same speed as the other motor, as motor A. So we set the same value here to 128, and then the other one has to be 0 because you have to give it a voltage difference for it to actually move. Okay, now why are these flipped? Why are these flipped? Well, it's just the way that it works out, the way that you wire the motors. And I had to do some experimentation, right? Is that you want to make sure that, because before maybe you would do, when I first wrote the code, maybe I wanted to do this, make this 0, in that, because it just kind of looks neater, but it doesn't work. If I did that, my motor B would going opposite direction from motor A, so I had to flip it, put it back like that, and then it would work. Now for move backwards, all I have to do is then take this, actually just take the code here and just flip which one is set at 0. So if you do that, motor A1B becomes 0, and B1B, and then B1A used to be that, becomes 0 here. Okay, I think I'll leave it at that. In the next video, what we'll do is just do some more experimentation, but actually coding using what we've learned to write some more movement commands, some DC motor commands. All right, hopefully that was interesting to you. I know that when you get a robotics kit with the DC motor, usually you're not going this deep into how it works, you're just focusing on the coding, but I wanted to do something a little bit different where we can understand a little bit more of the nitty-gritty on how the electronics and the mechanics work. All right, that's it for now. I will see you in the next video.